All right, so our first theorem for this section is called the tangent perpendicularity theorem. And what it says is that a line is tangent to a circle if and only if the line is perpendicular to a radius. So what does that mean? In order for a line to be tangent to a circle, that means it should hit the circle at exactly 1 point. So there's our 1 point where it hits the circle. It's called the point of tangency. And we're going to show that it is perpendicular to a radius. So let's draw a radius in. We need the center of the circle right about there. And then our radius goes from the center of the circle to the point on the circle. So it should look like that. And if this is going to be a tangent line, then the tangent line is always perpendicular to a radius. So it looks like that. So we can apply this theorem to a couple of examples. So the question is asking us, is line CD tangent to circle A? So the way we would answer that is, let's find our radius. Our radius is AB right here. So the question is line CD perpendicular to line AB? Okay, so we want to check to see if this is a right angle between AB and CD. So how can we check to see if that's a right angle or not? The way we can check is we can use this triangle right here and determine if it's a right triangle. And how do we know if it's a right triangle or not? We use the Pythagorean theorem. So let's try our Pythagorean theorem with 8 squared, 15 squared, and 17 squared. We want to see if they're actually equal or not. So 8 squared is 64, 15 squared is 225, and 17 squared is 289. 64 plus 225 gives us 289. Obviously, those two things are equal, and that means that CD is, in fact, a tangent line. Okay, so it's a tangent line because we just showed that the Pythagorean theorem worked, which means it's a right triangle, which means that AB is actually perpendicular to CD. All right, let's try a second example here. So is line AB a tangent for circle E? So let's find the radius. Our radius is right here, EA. So we want to know, is EA perpendicular to AB? So we're going to check to see if this is a right angle or not. And the way we're going to do that, again, is we're going to use the entire triangle, this thing right here, and we're going to decide if the Pythagorean theorem works for it or not. In order to do that, we do have to notice one thing. So we know the length from E to A is 9, but we don't know what CA is. But we know EA is the radius, and the radius has to be the same across the board. So EC also is going to have a length of 9. Okay, so now that we know that, that means CA is 9 plus 9, which is 18. And then BA is 12, and BC is 20. So we're going to try the Pythagorean theorem with 18 squared plus 12 squared equals 20 squared. And let's check to see if that's true. So 18 squared is 324, 12 squared is 144, 20 squared is 400. 324 plus 144 is 468, which obviously does not equal 400. So this is not a tangent line. So we now know this is not a right angle. Let's erase that. And we have now shown that AB is in fact not a tangent.